Hi everybody, today we're discussing box and whisker plots. This is part 1, so we'll just talk about how we construct them and analyze them. A key idea before we start, we have something called a 5-number summary that describes 5 important values in the data set. Those 5 values are the minimum, the first quartile, the median, the third quartile, and the maximum. We use these data sets or data values to help us construct our box and whisker plots. So a box and whisker plot represents a data along a number line by using the 5-number summary. We use it to show the variability in our data set, so how far spread apart or how much variability is there in our data set. So the box and whisker plot as shown right here, something else to notice about the box and whisker plots is that just like we had talked about with quartiles, quartiles divide our data into 4 equal parts. Now those equal parts meant equal number of data values within each interval, not equal length. So what's great about a box and whisker plot is we can tell where quarters of our data is. So in between the first 2 values of the 5-number summary, there is a quarter of my data. Same goes for the next 2, a quarter of my data, a quarter of my data, and a quarter of my data. By putting it on a box and whisker plot, we can also pretty easily see things like the interquartile range and the range because it's along a number line. Let's talk about how we construct a box and whisker plot now. So you already know how to find the 5-number summary because we did that when we found quartiles. So our very first step is going to be to order our data and to find that 5-number summary. That means to find the minimum, the maximum, the median, and our quartiles. In order to find our quartiles, we need to first find the median. I already have the minimum and the maximum written right there. That's what's great about ordering your data is you can clearly see the minimum and the maximum value. Let's go ahead and find the median. Again, that's finding our nice middle balance point. There's 3, 3, 4, 4, 5, 5. Now I'm left with 2 numbers in the middle right here, a 30 and 30. Now I know the number that's directly in between 30 and 30 is still 30. So our median in this case is 30. Since there are 2 numbers in the middle when we're finding our quartiles, our median is actually right here, so divide our data into 2 is right there. So here's my upper half now, and here's my lower half of the data. Let's go ahead and find our quartiles. And a reminder, that's just finding the median of the upper and the lower half of the data. So our third quartile, the median of the upper half, that leaves us with these 2 numbers in the middle, 33 and 35. The median of those would end with 34. We can either find that by finding the number that's directly in between 33 and 35, or by taking the mean of those 2. So adding 33 and 35, dividing by 2, gets us 34. Quartile 1 is similar, so we'll find the median of the lower half of the data. Again, we included that 30. We're left with 20 and 26. Now we need to find the mean of those 2 numbers in order to get the median. I know the number that's halfway in between 20 and 26 is 23. Again, you can find that by adding 20 and 26 and dividing by 2. I now have my 5-number summary. My minimum is 14, quartile 1 is 23, median is 30, quartile 3 is 34, and our maximum is 38. Our second step will be to draw a number line that includes the least and the greatest values. Now what's really important that we remember here is that our number line must be continuous and we must go up by the same step. So in this case, I decided to go up by 2s because my minimum was 14, my maximum was 38. Both those numbers are even. I have 14 all the way through 38 going up by 2s. Now we need to graph the points of the 5-number summary above the number line. So I know my minimum is at 14. I'm going to put a dot above 14 for my minimum. Quartile 1 is at 23. I'm going to find 23 on my number line. It's in between 22 and 24, and I will put a dot above 23. My median is 30. I put a dot above 30. Quartile 3 is 34. I put a dot above 34. My maximum is 38. I put a dot above 38. I have now completed step 2 because I've graphed all 5 numbers of the 5-number summary. Now we have to make it look like it's a box and a whisker plot. So a box and a whisker plot has a box around the quartiles. So the left end of the box is quartile 1, the right end of the box is quartile 3. I can go ahead and connect those two, constructing my box. What you might have noticed from the first slide is that there is a line in the middle of the box. Now it's not just whatever the middle is, it's where the median is. So I'll draw a line through my box at the median. I then have to connect my quartiles to my end values in order to make my whiskers, like whiskers coming off of the cat. So we start at quartile 3 and connect quartile 3 to the maximum. I start at quartile 1 and I connect quartile 1 to the minimum. I now have a box and whisker plot. Just to remember, quartiles divide our data into 4 equal parts. A quarter of my data is here, a quarter of my data is here, a quarter here, and a quarter here. They can be all different lengths, but there's still a quarter of my data. Let's talk about how we could use this to analyze our data. Example 2 gives you a box and whisker plots of the BMI of a 6th grade class. The minimum is at 17, quartile 1 is at 19, quartile 3 is at 22, and your maximum is at 38. We also have a median value at 21. Now, again, remember, in between each of those dots, each number of our 5-number summary fits a quarter of our data. They're different spreads, but they still have a quarter of our data. So the first questions ask you what fractions of students have a BMI of at least 22. This is where we're still going to have to remember all those important math words there. At least means they can be 22 or above. So 22, if I'm looking at my box and whisker plot, is the 3rd quartile. If 22 is the 3rd quartile and I want to go above, I'm asking what percent of my data is from quartile 3 to the maximum. Just like we had talked about, in between each of those numbers of the 5-number summary is a quarter of my data. So in between 3rd quartile to the maximum is 1/4 of my data, or a fraction there would be 1/4. This question could be a little different if I asked you what fractions of students have a BMI of at least 21. 21 is the median, which divides our data into halves, so I could say that half my data is above the median. Are the data more spread out below the 1st quartile or above the 3rd quartile? Spread out is another word that we use to talk about the range. How far apart are the values they're talking about? So let's first talk about how far apart are we below the 1st quartile. So from quartile 1 to the minimum. Quartile 1 is 19. The minimum is 17. The range of those two numbers, biggest minus smallest, is 2. The maximum is 28. Quartile 3 is 22. The range of those numbers is 6. Which one's more spread out then? Well, 6 is bigger than 2, so quartile 3 to the maximum, we're more spread out there. As we're looking at our box plot, that whisker is much longer than the other whisker. Since the whisker is longer, I know we're more spread out above the 3rd quartile. Our last step is to find and interpret the interquartile range of the data. What's great about having a box and whisker plots is that you already know the 3rd quartile and the 1st quartile. A reminder that the interquartile range is just the 3rd quartile minus the 1st quartile. The 3rd quartile in this case is 22. The 1st quartile is 19. So I know that 22 minus 19 is 3, and that is my interquartile range. As I go back and look at the box and whisker plots, that's also how long my box is, or how wide my box is. Remember from the last video that how we interpret the interquartile range is to say how spread out the middle half of my data is. So in this case, I know that the middle half of my data is spread out by about 3 units. I could also say that the middle half of my data varies by 3 units. I want you to figure out a way that you could write that as a summary statement to finish example 2C.